welcome to my channel. So in this video I'm going to introduce the solution to this Leetcode question called open the lock. So let's get started. So before we start to introduce the solution to this question, I would like to invite you to subscribe to this channel because it can really help me to grow. So thanks a lot. So let's restore this problem. You have a lock in front of you with 4 circular wheels. So each wheel has 10 slots, 0 to 9. So the wheel can rotate freely and wrap around. For example, we can turn 9 to be 0 or 0 to be 9. So the lock is initialized as 4 zeros and the string representing the state of the 4 wheels. And you are given a list of the dead ends. So that means if the lock display any of these codes, the wheel of the lock will stop turning and you will be unable to open it. So given the target representing the value of the wheels that will unlock the lock, return the minimum number of turns required to open the lock. So, or if -1 if it is impossible. So let's take a look. So for this example, let's say we have the dead ends as this, the target is 0 to 0, 2, so the output is 6, the shortest path is 6. Let's see, for the second example, suppose that end is 8, 4, 8, and the target is 0, 0, 0, 9, and the output is 1 because we can just turn 0, 0, 0, 0 to be 0, 0, 0, 9 with just one change, which is the last wheel. So I think we pretty much understand this. Let's take a look at the constraints. It says the dead end is the length of the dead end is between 1 to 500, and the length, each of the dead end is going to have the length as 4, so 4 characters, and the target has a length as 4, so and the target will not be in the list of dead ends, okay? And also the target and the dead ends I consist of digits only. So I think now I pretty much understand the question, and for the edge cases, I think one edge case, as already said, not possible, which is target is not in the list of dead ends. Another edge case I can think about is, what if the dead end contains a full 0, then we are going to return -1 directly without doing any processing. Otherwise, it is our general algorithm. So the algorithm is to use BFS to solve this problem. So for BFS, we use a queue. Let's go through this piece of code, which is implemented using BFS. So first of all, we have a hash set, which is not to visit. It is initialized as the dead ends. So you can see I define a helper function here to change array to be a set. So the not to visit set is initialized as dead ends. So this parameter is to record what are the codes that we have visited, or the code that is within the dead ends, which means we are not going to visit that. So otherwise, we start to fill in the queue with the start code, which is for 0, and we initialize the pass length as 0, which is the final thing we are going to return. And we start, while the queue is not empty, we are going to first get the size of the queue, which is the number of the codes within the current layer. And then we are going to pull out the code from the queue, and if the code is equal to the target, then we just need to return the pass length. Otherwise, we will need to get all its neighbors for this new code and push into the queue. So here I define another helper function passing in the code and the not to visit hash set. So let's see this one. So we have 2 parameters, the code and the not to visit. So initially we have the list of the string, which is what we are going to return finally. That is all the neighbors for the code, and not within the not visit hash set. And then we have the string builder initialized, which is to make it quicker for us to generate the new code from the original code. So for each of the character within the string builder, we try to get the original character record down, and at the end we are going to set the place to be the original character back, because we need to, because every time we just need to make sure that we change one character within the original code. So we set the current place as so I use +9 because the code, if we turn from 0 to 9, it is pretty much just -1 plus 10. So I just use +9 here and the modular 10, and then plus the 0 as a character. And if it's not in the visited, I'll just need to add a new code into the visited and add a new code into the result we are going to return finally. And the other way is we turn it clockwise, like we turn it just a +1, give it a +1. But the thing is, if the code is 9 and we +1, it could be 10. So we still need to have a modular here. And then if it is not in the visited, we add a new code into the visited and then add it into the result. So that's a helper function. So overall, that's pretty much it about this code. And if we ask about runtime, let's see what is a runtime. So for the runtime, it really depends on the target actually, and the that end. So I would say the most so I would say the worst case is we just visit all of the code here, which is 10 to the power of 4. So in that case, because we have the code to be fixed, has a fixed length, and we have like just a constant number of the maximum possibilities, which is 10k possible code we could potentially generate. So the runtime is going to be constant from that perspective. So that's it for this coding question and the solution. If you have any question, feel free to leave some comments below. If you have any, if you like this video, please help us subscribe this channel. I'll see you next time. Thanks for watching.